Hello, and today here at Lesson 9, we would like to look at another aspect of the paper, and that is the line of reasoning. So, first of all, let's look at the argumentative side of the paper. So, in a math modeling contest, normally a judge will see a lot of solution papers, and they're essentially about the same topic. And because there are so many things for the judges to read, they cannot spend too much time on each solution paper. And therefore, to win a good prize, you have to make your solution paper stand out in front of all the other solution papers. And since we have stated in our first ever video that all models are wrong but some are useful, you need to show through your solution paper that your model is more useful than that of your competitors. Of course, you do not directly attack your competitors, but you need to have the evidence to tell people that your model is useful. And therefore, in order to make the judges believe in your model, you have to show how the model is mathematical and logical. You cannot let them be confused. Finally, because you will only present a solution paper, the judges cannot ask you any questions. Therefore, your explanation should be as clear as possible and leave no room for the judges to question. Mathematical derivations are a really crucial part of your math modeling solution paper, and therefore, you need to do the following things to make sure that your derivations are clear. First of all, you need to have all variables clearly defined. That's why you need a variable section. And if needed, you may like to remind your readers of the variables right before your equation so that they don't quite forget what the variables are about. And in many cases during math modeling, you'll use a lot of formulas from subjects that is not math, especially physics and economics. Here, you should show the formula used and perhaps maybe even cite it. And during your derivation, show the key steps, that is, the application of formula or substitution. However, you do not need to show non-essential steps such as simplification. And as we know, equations need labeling. You label the final results but not the intermediate processes. This way your audience can separate and distinguish between the final results and the processes. And for questions you may encounter about building a ranking system about something, you may need to write your own equation, which is, in this scenario, you should try to justify every part of the equation. For example, each term. What does this term stand for? Why do we need it? And each operation. That is, why do you use exponentation? Why do you use multiplication? Or why addition? And that is how we show mathematical derivations. Next is code. Code is not an essential part of math modeling, but they're strongly recommended, especially for automating processes, because the calculations sometimes they can be very tedious. Often, you have the opportunity to put code in the appendices, since in certain contests, you do not have a limitation on how much material you can place into appendices. And you will use code for two scenarios. If you use it only for automations, you can simply ignore it in your solution paper, because using code is the same as hand calculating, just faster. However, if you clearly use an algorithm, you have to explain your algorithm clearly. If it is a pre-existing algorithm, which is most of the case, you should state the correct name of it. And to help your audience understand the algorithm, visualize it with a flowchart. Finally, about figures and tables. Of course, figures and tables should be clearly labeled and have good captions. They improve clarity a lot. And you don't want to leave your audience looking for a figure upon seeing text, like seeing text and going really confused and wanting to find a figure. You should, in your text, point to the figure for your audience, like, look here, the figure is here. and just look at it. And whenever possible, use figures over tables because figures tend to be more clear and easier to read. Finally, whenever you find that you cannot fully explain something verbally, for example, a process with a lot of logical components in which a textual organization may not be good enough, use a visual. And that is what I have to talk about the line of reasoning.